Hi, welcome to BC Video 11.2, 11.3 Part 2, the angle between two vectors and orthogonal vectors. Now, all of this brings us to the angle between two vectors. So if you have these two vectors u and v, and you're interested in finding the angle between them. Now, first of all, that angle is defined to be a positive angle between 0 and pi radians, which in degrees would be between 0 and 180. Then it's going to show you how to find it. Here's a theorem. If theta is the angle between two non-zero vectors u and v, then instead of the formula saying theta is the inverse cosine of, which they could have said, they're just leaving it as cosine of theta, which is the angle between the two vectors, is the dot product of the two vectors divided by the product of the magnitude of the two vectors. Now remember, the dot product will give a constant, a scalar, and the magnitude of a vector is a scalar. You're going to multiply those two scalars, divide the top scalar by the bottom scalar. You will end up with the cosine of theta equals a number, a real number. Now, the proof of this theorem, I'm just going to quickly run through this proof. And that is, first of all, you have to realize that this is the vector. Here's u and here's v. This vector here pointing from here to here is actually vector v minus vector u. So if you were to attach, if you were to take v and make a parallelogram with negative u, because we have to add negative u, so that would come down here, and you would draw this, you would get that this vector here, the diagonal, which is equivalent to this vector here. Anyways, now that you've got that, it works by the law of cosines. If this was c and a and b, you'd have c squared equals a squared plus b squared minus 2ab cosine c, which is equivalent to this right here. Now, of course, the lengths of the sides are the magnitudes of the sides. And then we had that property we just talked about where the dot product of the vector and itself is the square of the magnitude of that vector. So if you actually perform this dot product, because of the distributive property, you have v times v minus u times v minus u, and then you have v dot product with v minus u dot product with v, etc. And then, of course, that property comes back. The dot product of a vector with itself is the square of the magnitude of that vector. Same thing here, and then there's minus 2 of these because that is commutative. Now we go back and we go, okay, now that we know that this left side is equal to this quantity, let's replace the left side by that quantity we just found, and that's equal to the right side, and then you just kind of move things around and you'll come up with that answer. So here's an example. Here's a vector. Here's the magnitude of vector u and vector v, and it says find the angle. It says and the angle between the vectors is pi over 3. The question is find the dot product of u and v. Okay, so we're looking at number 10. So here's our formula. So we have dot product of u and v, which is what we're looking for. They gave this the magnitude of u is 40. They gave us the magnitude of v is 25. They gave us theta is 5 pi over 6. Cosine of 5 pi over 6 is negative root 3 over 2. 40 times 25 is 1,000. And you isolate your dot product of u and v, and you get negative 500 root 3. Here it's actually find the angle between the two vectors, so we're going to do number 12. So we start off with our formula right here. And then we have the dot product of the vectors, which is the product of the x components plus the product of the y components. The magnitude of vector u is square root of 3 squared plus 1 squared times magnitude of vector v is square root of 2 squared plus negative 1 squared. Simplify all that down, and then of course they actually want the angle, so we do have to take the inverse cosine of 1 over root 2, which turns out to be pi over 4. Here they're asking you whether the vectors that they give you are orthogonal, parallel, or neither. So they give you them in linear combination form. So I would rewrite it in component form. Same thing here. And, if you don't believe me that this is the same, you could always rewrite it. Are they orthogonal? Remember, orthogonal is the same thing as perpendicular, and that's going to happen if the dot product of the vectors is 0. So again, product of the x components plus product of the y components, and it turns out that that is not 0. So they are not orthogonal. Are they parallel? That would require one of the vectors to be a scalar multiple of the other vector. So multiply the scalar c through, set the x components equal, the y components equal. If you end up with the same value of c, which we did, the